Hello everyone, this is Roger Lapuh speaking. I'm Director of Product Management here at Extreme. Today I'm going to talk to you about how to automate your network operations with Fabric Connect. I'm going to take the first section, and after that Ludovico Stevens will be doing a demo basically illustrating what I'm going to be talking about. So let's look at the agenda. We're going to look at the evolution of the network, why fabrics make sense, and then look at that in the context of the network lifecycle. The lifecycle and how to automate the elements of the life cycles throughout. And then we'll do the demo. So before that, let's look at this quote from Forrester Research. They say, a single business-wide switching fabric will become the de facto architecture of today's networks. So what does that mean? If you look at today's enterprise networks, we have discrete elements like campus core, edge networks, branches, data centers, metro areas. What will happen is that those elements will be combined in unified end-to-end fabrics, and this will allow you to automate end-to-end your network. So let's look at the network lifecycle and then see the different ways to automate that lifecycle. So you basically first install the hardware, then you configure your hardware, you onboard the devices, you deploy network services. What I mean with services is VLANs, VRFs, connectivity services for your internal customers. Then we talk about the daily operations, how you can automate that, and then how do you keep the lights on in your network, basically assure the network health. So and then we looked at that in the context on how and what to automate in this infrastructure. But before we do that, let's look at two different ways to automate: the implicit way of automation and the explicit way of automation. The implicit way of automation means we take care of the automation. We, as your network vendor, we provide protocols, network protocols for the automation, and we can test them, we can run them, and then the network behaves the way you want. Then there is the explicit automation, which means that somebody, you yourself or some third party, writes scripts to automate certain parts of your network and then program APIs in your infrastructure. That means you spend your resources, or you have either people or money, to automate certain parts of reoccurring processes in your network infrastructure. Typically, both of these things, implicit and explicit, is required. But let's talk about what makes sense where. Let's start with the hardware installation. Hardware installation, that's the part you can't automate really, because somebody has to go there, put the switches in place, connect the fiber up, and that's a manual process. But from here on, when the switches are there, powered up, connected, there is where things can be automated. So again, blue means implicit automation, yellow means explicit automation. So let's look at this infrastructure configuration automation implicit way. So somebody connected the fabric up, and now it forms itself automatically. There's one seed switch, and then from there on, all the other devices on board automatically connect to the fabric, and you have an end-to-end fabric infrastructure that provides, that is ready for you to then deploy your network services on top of it. Now, once the fabric is up and running, and we'll show you that in the demo, then the devices can onboard to the network management tools implicitly, so you don't have to worry about that. They onboard to your on-prem, and they onboard to your cloud-based network management tools automatically. I'm going to show you that in the demo as well. Now, how this would look like this way. So you have your fabric infrastructure, you have then the devices that connect through the internet or whatever, or through your corporate infrastructure to the network management tools, and then pop up in the screen, and you can see those devices, and then those devices are ready to be individually configured. So now, once the network services are, now that the infrastructure is ready, the device is registered, now you're ready to deploy network services. So now there's two different ways. There's the implicit way again, and the explicit way to deploy those services. Let's first look at the implicit way. Basically use network protocols such as EAP authentication or EPNIP, MAC-based authentication, to authorize a user, and then radius to tell the switches where to place those users into. So here in this scenario, you deploy segments to the network based on your user intent. So for example, you have a user segment, you have an IoT segment, you push those segments down to the infrastructure. So like that. And here in this case, the user and the IoT server are manually attached. You can do that through the network management provisioning infrastructure, but you can also automate that like shown in the demo in the second part of this presentation. Once the segments are ready, then the clients can join. So the clients are connected to the infrastructure, they get authenticated, and then assigned to the correct segment based on their login credential or MAC addresses for that matter. You can also not only assign them to the right segment, you can also deploy a filter, an ACL, a policy to the user based on their login credentials. So now the services are deployed, users are in the network. Now during your daily operations, add moves and changes happen. That means users move around from one switch to the other. This is a wired example here, but this works for wireless as well. Users walk around in your infrastructure, get connection to a different location in the infrastructure. And what happens is with, again, implicit automation, your configuration moves with the user itself, whether this is a user a person or whether it's a device. The connectivity to the segments are dynamically moved. That is not only provides instant connectivity, but it also cleans up your infrastructure. That means your infrastructure is always clean and there's no lingering configuration in the infrastructure. That means it's also not, there's no security hazard of configuration elements in the infrastructure that you don't want to have. So besides that implicit automation, there is also, in many cases, explicit automation required, where third-party products, tools are integrated, or business systems need to be integrated. Those are very specific targeted use cases for you, and these things typically require a workflow that is written by yourself or by your somebody that you pay for. You can use extreme professional services for that as well. And these are very targeted, and we have a very nice GUI tool to provide those those scripting capabilities, workflows with our network management tools. In the demo, you will also see a little bit workflow used as well. So once the services are deployed, the users are in the infrastructure, you want to make sure the lights are always on, the network is up and running and stable. And for that, we also have, you can call it implicit automation with our cloud monitoring capabilities. The devices are constantly monitored, or can be, if you desire to do so, can be constantly monitored. The device health, the client health, the Wi-Fi health, the network health. Basically, a 360 view of your infrastructure can be provided. And the good thing is with cloud-based capabilities, cloud-based network management, surveillance, not surveillance, but monitoring of your infrastructure, then we can provide you always the latest capabilities. We can add new capabilities, and you can benefit from those quick new capability adds instantaneously, because they are there at your discretion, at your for you whenever we do provide new functionality. There is no project needed that you would have to run to get these capabilities up and running in your infrastructure. So we're basically expanding those 360 view for networking to also 360 view fabric, so that you have a physical view of your fabric as well as logical views of your fabric. So a lot going on there in context of network visualization. So now let's look at the demo part of this section. In the demo, we're going to look at the VSP platform with Fabric Connect, and how we, with release 8.03, and how we onboard with zero-touch onboarding the devices to the network management tools, how the fabric is automatically formed, how APs are automatically connected, how the users get a zero-touch client experience. So the whole automation capabilities is going to be demonstrated here. This is the topology we're going to run the demo on. And to securely access the network management segment, we're running this E-tree. So Ludo is going to talk about that E-tree here. This is a secure way for each device that is booted up by default to onboard to the network management segment. So they can't talk to each other in the infrastructure, so they can securely only communicate to the network management segment so that we can then provision them as depicted before. So now let's go and start look at the demo. Ludo, please go ahead.
Hello. In this demo, we're going to demonstrate VSP AutoSense functionality, which will be new in VOS 8.3. VSP AutoSense allows a VSP to automatically form a fabric with other VSPs without any user intervention or configuration. Also, connections to FA proxy switches like Exos and ERS are fully automated. The concept of an onboarding private VLAN E-tree ISID is introduced. Any switch or AP or end station can connect to XIQ or X3 Management Center XMC via the onboarding ISID without the possibility of any loops. Phone detection is also integrated into the VSP AutoSense. In this setup here, we have a number of VSPs, and we have an access point, a telephone, a client, and a server. In this setup, the VSP 7200 will be acting as a seed switch, which has already been onboarded and on which some configuration has been made. The configuration is needed for two things. The onboarding ISID used by the zero-touch fabric will need to be bridged onto a segment where a DHCP server is available and XMC and Cloud IQ can be reached. The other configuration required on the seed device is going to be the nickname server. This is so that other VSPs, when they form and join into the fabric, can be allocated with a nickname, which will then allow them to participate in the fabric and generate multicast traffic. We shall inspect the initial configuration of the 7200. We shall then proceed to completely flattening the configuration of all the other VSPs and also the Exos and the ERS, which are part of the setup as FA proxy devices. The expectation is that all the VSPs, as well as the Exos and the ERS, will come back and will be reconfigured automatically without any manual configuration and will reform the fabric automatically. The access point will automatically onboard itself again and request the ISIDs it requires. The telephone will automatically be put into the voice VLAN, and the client will be able to perform EAP authentication and be onboarded on the segment where it can reach the server, which will also be onboarded using endpoint tracking, which will be the technology that we use in the data center for automating server attachment on the top of rack switches. The whole setup uses in-band management only for all VSPs and the Exos and ERS fabric attached devices. This is because we want to demonstrate how the fabric self-forms before a VSP or an Exos or an ERS can then use the onboarding ISID to connect to XIQ and XMC for final onboarding and configuration. And this is Extreme Management Center, which shows the map of the fabric, which is already operational. We also have a terminal window with connection to all the serial ports of all our switches via a terminal server, so that we can see what happens as the devices are rebooting with no configuration. And we have another terminal window with SSH connection to all the devices, which we have right now because the fabric is up and running. We shall inspect on the seed device the additional configuration which was made. If we inspect the VLANs, we'll see that there is a VLAN, an onboarding VLAN, which has default ID 4048, which is a private VLAN. The onboarding VLAN has an ISID associated and is therefore an onboarding layer 2 VSN ISID. A private VLAN has a concept of ports can be promiscuous or isolated. Normally, all access ports will be in isolated state, and devices connected and forming the fabric will have connectivity on the isolated ports. What we did change on the configuration of the seed node is to enable promiscuous mode on port 16, so that the onboarding VLAN can bridge this traffic onto the segment where the DHCP server is located. And finally, the other configuration which was performed on this node was to activate the nickname server, so that this VSP can distribute nicknames in this particular range. We're now going to proceed to completely flatten the configuration of all these switches, basically all switches except our seed VSP. To do that, we're going to use a handy script that we're going to run against our VSPs except the seed. This script will simply make sure that the VSPs are using the default config file, which is config.cfg, and then proceeds to make sure that that file is deleted and does not exist on the switch, and then reboots the switch. Therefore, the switches will power on as if they were shipped from factory. We shall execute. We shall check the results. The commands were correctly accepted. Good. We shall now proceed to delete completely all these VSPs where we flatten the configuration, and we'll also delete the ERS and the Exos devices, which will go in factory default shortly afterwards. To do that, we will do delete device, and with this checkbox here, we ensure that the device is completely deleted from the XMC database. And we shall inspect our map, but now we only have our seed VSP. We shall now go onto the serial port. We shall factory default our Exos switch. This is done using the unconfigure switch command. Yes. And we shall do the same thing on our ERS 5900. And this here it's done by doing boot default. Yes. We shall now expect to find that VSPs, Exos, and ERS switches re-onboarding under the XMC Discovered tab. And we shall monitor progress by inspecting the serial port on these devices. We shall look in particular to the 5520 24W. Notice that links are starting to come up and adjacencies, ISIS adjacencies, are automatically forming. Notice that the nickname has automatically been assigned by the nickname server. This means that now this VSP is able to generate multicast traffic, multicast trees in the fabric, which is needed for the DHCP request, so for the switch to obtain a DHCP IP address on the in-band management VLAN, which we can see here has now been assigned, as well as DNS being set to the DNS servers and the DNS name. The ZTP process now has begun, and as you can notice, switches start to get onboarded onto XMC. We now have to wait for ZTP to complete the staging. The process is fairly slow to allow an operator to intervene. The discovered devices are allocated to the desired XMC site, which here is World POC Zero Touch Fabric. And then the onboarding config is staged to onboard those devices onto that particular site. Once the configuration is staged, the devices will disappear from the Discovered tab, and we shall find them under devices in the XMC site. We can see the ERS 5900 has only just arrived. The ERS has been onboarded and the Exos has just arrived. All devices have been discovered and onboarded. We should now find them in our XMC site. We shall now inspect our map, which needs to be rearranged. That's it. Our fabric is now fully operational and onboarded without any user intervention or configuration. We shall now take a closer look at the 5520 24W, where we have an access point running fabric attached and a telephone connected. And we'll see how detection has operated here. Again, we shall connect by SSH. We shall look at what interfaces are up, and we shall record what those port numbers are. we shall inspect our LODP neighbors, and we can see that we have an extreme wireless access point, AP505, connected on port 16, and we have a telephone and a Avaya telephone connected on port 17. And then we have 3 connections to other VSPs and 5520s in our setup. We inspect the configuration of these ports using show interface gigabit Ethernet config. We can see that AutoSense has again detected an NNI role for the interconnects to the other VSPs. It has set a voice role for the port where the telephone was connected and has detected an FA WAP role for the port where the access point was connected. If we inspect our ISIS adjacencies, we can see we have ISS interfaces on the NNI interfaces. And if we inspect our fabric attached neighbors, we can see that we have a wireless access point connected on port 16. If we inspect the fabric attached interfaces, port 16 has already automatically been enabled as a fabric attached interface with message authentication enabled, since extreme access points all support message authentication. Extreme access points will perform signaling with fabric attached. So if we expect fabric attached signaling, we might find assignments, and we do. On port 16, the access point is requesting to have 3 VLANs and their ISIDs as their corresponding ISIDs. If we look at what ISIDs are programmed on the port, we shall find that these ISIDs are all programmed in queue tagging. The onboarding VLAN is still present as untagged. This is the VLAN where the access point performed DHCP and obtained its initial IP address for management purposes. The other 3 VLANs are signaled by and requested by the access point and can be used for onboarding wireless users. Again, no configuration was required on the VSP side. Finally, we shall take a look at the port where the telephone is connected. When the onboarding workflow was executed, the voice VLAN and ISID were configured. We can see that information if we do the show AutoSense command. Voice was assigned the ISID 2,800,200, 800,200, and VLAN 200. So with expectation here is the voice VLAN for the telephone will be tagged. If we look at the ISIDs on the port where the telephone is connected, we shall see that we still have the onboarding VLAN as untagged, which will be used by any PCs or devices connected behind the telephone, but the telephone itself will be using the voice VLAN, which is tagged 200 and will be ISID 2,800,200 in the fabric. So the onboarding for the telephone has also been automated. We shall now take a closer look at the 552048T, where we have a client PC which we want to onboard using EAP authentication. The authentication should have happened by MAC-based authentication, so we shall inspect the switch to see if the MAC has been authenticated. You can see here that the PC on port 15, which has MAC address 5D F1, is authenticated, and the radio server has provided an ISID and no VLAN ID. This means that the PC, the client, will be onboarded untagged on this layer 2 ISID. If we inspect the ISIDs on the port, we will see that the ISID provided by Radius has been configured as untagged on the port. The onboarding VLAN also remains on the port because we may want to authenticate other devices on the same port. We're now going to come and look at the VSP 7400 again, and this time we want to use endpoint tracking to automate server VLAN attachment. To do this, we're going to add some additional configuration of 7400 to make it operate using endpoint tracking, which is typically used in the data center for server connectivity. To do that, we're going to run a workflow on this VSP 7400, which is called VSP EPT enforce. Our server is connected on port 11, so we only need to enable this port for endpoint tracking. We want to enable endpoint tracking globally and on the ports. We will want to set an ISID offset. In case the radio server only returns a VLAN ID, the offset will be used to derive the ISID. And we also want to enable visibility mode so that we get all visibility of server MACs on XMC, even if these MACs are learned on static bindings. Next, and we run the workflow. The workflow was successful. We can now go to our 7400 And we can inspect endpoint tracking, which is now enabled with the offset, ISID offset, and visibility mode enabled. And we can check the endpoint binding table. And notice that we already have a MAC address, which has been authorized by Radius onto VLAN 0 and ISID 2,800,210. So the same ISID where we onboarded our client. We shall now go and have a look at our server. Notice the MAC address, this is our server, and it has a static IP of 21.210.100. We shall now also look at our client. And our client has MAC 5D-F1 and has this IP address here, which is in the same subnet domain, so it should be able to reach the server. The server is reachable. We now return to Cloud IQ and refresh, and discovery of our VSP 4900 and VSP 7400 is now complete with all the information available. And we can use XIQ for advanced monitoring of our switches. There's not a lot of data yet, as the device has only just been onboarded. This information will become more interesting as the data is collected over time. Thank you for watching. Be extreme.
Thank you, Ludo. So let me conclude here with, let's look at the network lifecycle again. So we talked about the different elements of the lifecycle and how we can automate the lifecycle. So we deployed a fabric from scratch by flattening all the configuration elements. And then we saw how the device is onboarded automatically to XMC, your on-prem tool, or XIQ, and XIQ. It's actually onboarded to both of them at the same time. And then we looked at how to deploy, connect user segments, connect users to it implicitly, but also we saw a couple of workflows that were used in this demo. And then we saw a little bit of the Cloud IQ user interface and how you can manage and operate and look at your devices on there as well. So with this, this concludes today's view on network automation with Fabric Connect, and thanks a lot for listening. Bye-bye.